Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. 2-heptanone, CH3COCH2CH2CH2CH2CH3, has 7 carbons with a ketone at C2. The strategy is to build a terminal alkyne with the right carbon count, then perform Markovnikov hydration, Hg2 plus H2SO4 H2O, to give a methyl ketone. Moving on to the next step. Identify the target. 2-heptanone is equal to CH3COCH2CH2CH2CH2CH3. It has 7 carbons, ketone at position 2. Moving on to the next step. Retrosynthetic analysis. Hydration of a terminal alkyne, Markovnikov, gives a methyl ketone, RCCH plus H2O Hg2 plus H2SO4 RC is equal to O, CH3. So we need 1-heptine, CH3CH to CH to CH to CH to CCH as Y to get to heptanone. And for the final step, build 1-heptine. 1-heptine has 7 carbons. We can make it by alkylating a terminal alkyne anion. If we start with ethine, HCCH, 2 carbons, and treat with 9H2, we get the acetylide HCCNA X. Then alkylate with N, C5H12Br, N-pentyl bromide, C5H11Br, 5 carbons HCC plus N, C5H11Br HCC5H11 is equal to 1-heptine, Y, 7 carbons total. Hydration of 1-heptine with H2O Hg2 plus H2SO4 gives to heptanone. Verify option B ethine to C plus 9H2 HCCNA X plus N C5H12Br N-pentyl bromide, which is C5H11Br 5C 1-heptine Y 7C hydration to heptanone. This is correct. Check other options. Option A propine 3C plus N C4H9Br 4C 1-heptine. Wait, propine is CH3CCH, 9H2 deprotonates terminal H to give CH3CC. Alkylation with N, C4H9Br gives CH3CCC4H9 is equal to 2-heptine, internal alkyne. Hydration of internal alkyne gives a mixture of ketones, not exclusively to heptanone. Incorrect. Option C1-hexine, 6C, plus CH2Br, 1C, 7C alkyne, but CH2Br, methylene bromide CH2Br2 or bromomethane CH3Br, is ambiguous. Using CH3Br gives 1-heptine, but NCH2Br is not a standard reagent, it would be CH3Br for 1C addition. Also the reagent written is CH2Br, which is unusual. This route is not the best standard approach. Option D 1-pentine, 5C, plus C2H5Br to C. 1-pentine has terminal alkyne CH3CH to CH to CCH, 9H2 gives CH3CH to CH to CC, plus C2H5Br gives CH3CH to CH to CC. C2H5 is equal to 3-heptine, internal alkyne. Hydration gives a mixture, not to heptanone. Incorrect. Only option B correctly produces a terminal alkyne, 1-heptine, that upon Markovnikov hydration gives exclusively to heptanone. Therefore, the correct answer is B. Therefore, the correct answer is option B.